Hi and welcome to my fifth lecture on the series Chemistry 111. Uh, we are going to today talk about periodic table of elements, hopefully making it easy for you to understand. I'm planning to do at least a couple of videos on periodic table to cover the entire periodic table uh, chapters, which in test books are divided into different chapters. Hopefully, for continuity's sake, I'll do it in 2 or 3 videos back to back and cover the entire gamut of periodic table properties of standard elements, transition elements, and others. Um, as a part of the outline, what we need to understand about periodic table is as follows. First of all, what is periodic table? And as the name suggests, periodic table is simply a table of elements. So it is simply a table of elements. And these elements are arranged in increasing atomic number, which are nothing but the number of protons or the Z value in the nucleus. This is important to understand because by mid 19th century, there was a lot of information that was available on various elements, and scientists were trying to arrange these elements in various tables to better understand their properties. The first scientist who really put forward a comprehensive table was the Russian chemist Dmitri Mendeleev, where he arranged the elements in ascending order of their atomic masses. Subsequently, it was found that by doing that, not all the elements were nicely falling in rows and columns in a proper order, and Moseley and later on, of course, Luther Meyer from Germany actually found that it was better to arrange the elements in ascending atomic number rather than masses, and this finally led to our modern periodic table, where we do arrange the elements in increasing order of their atomic numbers. And these are, of course, arranged in rows and columns. Why is this important? Because this helps us to understand the properties of the elements. All the elements which have similar properties will fall in a group, vertical group, a vertical column called group. And also it helps us to predict the undiscovered elements just by noticing which group it is falling, and we can predict that there would be an element that potentially can be discovered which belongs to that group. So it's important to understand the periodic table from that standpoint of view. It helps us to understand the electronic configuration, the reactivity, and various characteristics of elements. How elements are arranged, we just spoke about it. They are arranged in ascending order of their atomic number. So if you take a periodic table and you are arranging the elements in various horizontal rows called periods and vertical columns called groups. So these are periods and these are groups. Well, as we go from left to right, each element will have increasing atomic number, and as we go down also they will have increasing atomic number. Okay, so that's how they are arranged. Then we will learn some basic characteristics on the basis of which we will be explaining the periodic trends in various properties. we'll be explaining based on this basic characteristic how does the atomic and the ionic size varies as you go left to right in a period or top to bottom in a group. We'll explain electronegativity En, the first ionization energy IE1, the electron affinity Ea, metallic character, and the acidity and the basicity of oxides. So let's talk about periodic table. Periodic table, the first important thing I would write, there are four main characteristics that we need to understand. I'm going to write it here, so I will draw the table there. The first thing you have to understand is that it is a table of elements arranged in increasing atomic number. Second thing you have to understand is as you arrange them in a table, you arrange them in various rows which are called periods, and they fall in columns which are called groups. Third thing to understand is that there are 7 periods or rows and 18 groups or columns. Fourth thing to understand as a basic knowledge about periodic table is all elements in a vertical column or in a group have similar properties. Now you have to understand property of an element depends upon its valence electrons, meaning how many electrons are there in the outermost shell. That is what determines the reactivity of an element. So those are the electrons that will be shared with other element to form bonds. So all the elements in one group have the same number of valence electrons, therefore they behave similarly. And this number, how much valence electrons are there, corresponds to their group number. Meaning, if I tell you that there is an element in group 4A, and I ask you how many valence electrons does that element have, your answer would be, since it belongs to the group 4A, the valence electrons, or what is called as the number of electrons in the outermost shell or the outermost energy level, would be 4, because that is equal to the group number. Okay, so that's what you need to understand. And the last thing you need to understand before we just draw the skeleton for the periodic table is that the period, which is ranging from 1, 2, 3, 4 to 7, each period indicates a new shell being added. So the second period element will be a new shell added, the third one would be 3 shells added, like that. So as you go down a group, as the period increases, the newer energy levels are being added, so atomic size will keep on increasing down a group. Okay, so this period number is showing you the energy level, the outermost energy level. So if I say there is an element which belongs to the 4th period, you will say it will have 4 energy levels. Okay, so this is the basic that you need to understand, and let's go ahead and draw a skeletal diagram for a periodic table. Since I am on PowerPoint, I'm just going to go ahead and add a table, and basically say I want to add 18 columns and I want to add 7 rows called periods. So these are this is my periodic table. Now it doesn't look like our classical periodic table and I'll tell you why in a minute. But let's just say this is our periodic table and let's be sure that we got our numbers correct, which are as we said, the number of periods will be 1, 2, 3, 4, 5, 6 and 7. The periods are what are called the horizontal rows. These are the periods. So there are 7 periods. Columns are the vertical columns, are the groups, and pay attention to how I label them. 1A, 2A. Then from 3 to almost 10, so I'm going to count this. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So these are 10 columns which are the B group. Remember this was 1A and 2A. Then I would pick up 3A, 4A, 5A, 6A, 7A and 8A. Okay. So now we have so far labeled the periods correctly, we have labeled the columns correctly. Again, as a piece of repeating the information from a few minutes ago, remember all the elements belonging to one group. So this group, all these elements will have similar properties. So this element here, this element here, this element here, all of them will have similar properties. And that means they have the same number of valence electrons in their outermost shell. The outermost shell number will vary. So this element outermost shell or the outermost energy level is 1. This element here will have outermost energy level of 2. But each one of them will have only one electron, valence electron, meaning they will have only one electron in the outermost energy level or shell because they belong to group 1A. And these are called as alkali metals. Same way, all of these elements which belong to the second column, this element, this element, this element, this element, this which belong to the second column, they all contain 2 electrons in their outermost shell, and therefore they have similar properties. Of course, these 2 electrons are in which outermost shell will vary depending on which period they are. So for example, this element here is in period 3. So it will have 2 electrons in the outermost shell because it belongs to the group 2A. However, those 2 electrons will be in the third energy level or third shell. Same way, say I take this element here. This element, because it belongs to the 2A group, it will have only 2 electrons in its outermost energy level or outermost shell. And that outermost energy level or outermost shell will be the 6th because it belongs to the 6th period. Okay, so these group, the group 2A, all these elements together are called as alkaline earth metals. Okay. The elements belonging to group 8A, this group here, these are called as the noble gases. And the reason they are called as noble gases or inert gases is because they are non-reactive. They do not react with other elements. And the reason for that is they are happy. They are happy because their outermost shell has 8 electrons, so that is what is called as a complete octet. Any element which has a complete octet, meaning 8 electrons in the outermost shell, is the most stable and they do not react with other elements. This group 7, is the group called halogen. Halogen, halogens. That's where you have fluorine. I'm sorry, not from there. Fluorine, chlorine, bromine, and iodine. Fluorine, chlorine, bromine, and iodine. Group 6A is oxygen group. Oxygen and sulfur go hand in hand. 5 is nitrogen with phosphorus below it. 4 is carbon with silicon below it. And 3 is the boron. So these are some of the elements you need to know. One being hydrogen and helium. Now I'm going to block some of the squares which do not have any elements in them, because the way I drew the table now was just a simplified table. So I'm going to fill in some of them. So for example, there is no, oh, I'm not able to fill that correctly. How about this one? Okay. So this here, all of this is not having any element here. And same way from the group B actually starts from period 4 to period 7. So above period 4 there is no elements in that. So we shouldn't be drawing this up to here. And similarly, in the first period there are only 2 elements, which is hydrogen and helium, so there is nothing here. So if I have to draw the outline, I would have now, to make it a little more perfect, I would have drawn the outline in this manner. So I would have I'm drawing it in the yellow highlighter. So the outline of the periodic table would have been something like this. Okay, so now you can understand why it is in a little bit zigzag manner, because there are no elements in between. All these red lines are where there are no elements. Okay, so far we talked about the periods, we talked about the columns, we gave various names. The main ones are alkali metals, alkaline earth metals, noble gases, halogens. You have to understand that as you go from left to right, or as you go from top to bottom, doesn't matter, as you add new elements, the number of protons in the nucleus is increasing. In other words, number of electrons is increasing. Now, if you are in a same period, which is in a same row, if you're in a same period, right, as you are adding electrons, those electrons are being added to the same energy level, because all of these elements, say we are talking about period 4 in this case, are belonging to the period 4. So the electrons are being added to the same energy level, the fourth energy level. Whereas when you go down in a group, although all the elements in the group will have only will have the same number of valence electrons, but these electrons are being added to increasing energy levels. So for example, in group 1a, you have only one electron in the valence shell, but that valence shell is increasing. So here there will be one electron in the first shell, there will be only one electron in the second shell, third shell. So as you go down in a group, as you are adding more shells, of course the size of the atom will increase. So these are the two important points that you need to understand. And the last thing that you need to understand here is that the electrons, when they are added to a shell, they are also added to a particular orbital. And based on the orbital, we call them as S block or the P block or the D block elements. So these elements, the group 1a and 2a together, these elements are called as the S block elements. So let me be sure I write it correctly. So these are called as the S block elements, which are the 1a and 2a. So these are the S block elements. And the reason they are called S block elements or S block metals is because the valence electrons are in the S orbital. Then this group of elements here are called as the P block elements, because the valence electrons are added in the P block. So these are the P block elements. And then this group here in between the B group, this here, are called as the D block elements. The exception is there are two elements in period 6 called lanthanum and period 7 called actinum. Between that element and the next element, here and here, between these two elements, there are 14 elements more, where the electrons are added to the inner n-2f orbital, and those are called as the F block elements, and these are represented separately at the bottom as the lanthanide and the actinide series. So there are 14 elements in here. So these are the F block. So the upper series is called Lanthanide series. And the lower series is the actinide series. So these are the S, P, D, and F block elements that you need to know. So quick summary. So far what we have spoken. We have said periodic table is a table of elements arranged in increasing atomic number, and these elements are arranged in the rows and columns, rows being called periods, column being called groups. There are 7 periods and 18 groups. All elements in the same group will have same properties because they have the same number of electrons in the outermost shell called valence electrons, and the number of valence electrons will correspond to the group number. So if I take carbon, for example, which belongs to group 4, and I ask you what is the valence electrons in group 4 for carbon, you'll say since it belongs to group 4, carbon will have 4 valence electrons. Or for that matter, silicon also belongs to group 4a, so it will also have 4 valence electrons. Only difference between carbon and silicon would be carbon, because it belongs to period 2, will have the 4 electrons in the second shell, whereas silicon will also have 4 electrons because it belongs to the same group, but those 4 electrons will be in the third shell because it belongs to n equal to 3, the third period. So we talked about that. We also spoke that as you go from left to right in a period as you go left to right, what happens is the electrons are being added to the same shell. So because if n equal to 1 or say n equal to 2, whatever, so that shell is what is keeping on getting the electron, extra electron as you go from left to right. So it is in the same shell. On the other hand, as you go down a group, the number of electrons in the outermost shell remain the same, but one new shell is being added. So if you say, I'm showing here, say group 2a. So group 2a, the first member, which is this member here, will have 2 electrons in the second shell, because we don't have first period, we have second period. So second period meaning n equal to 2, meaning second shell. So in the second shell there will be 2 electrons. Then the next member is also going to have 2 electrons because they all belong to the group 2, but the next member is period 3, so it will have one more shell, and it will be the 2 electrons will be in that. The next will be period 4, but the same group, so it should have 2 electrons, but it should be on the 4th shell. So 1, 2nd, 3rd, 4th, so I'll need to draw one more shell and draw the 2 electrons on that shell. So you notice as you go down a group, extra shell is being added, therefore atomic size going down a group will increase, and we'll talk a little bit more about atomic size in the next video, what happens when you go from left to right in a period. Okay, then we finally concluded about S, P, D, F and F block elements. S block element is group 1 and 2a because the electrons are added in the s orbital. The P block elements are group 3 to group 8a, and they are called P block because the electrons are added in the p orbital. Then the transition metals are the D block elements. Inner transition metals are the F block elements, which lie between lanthanum. Basically they lie in the 6th and the 7th period of the transition series, but between lanthanum and the next element, and between actinium and the next element, there are 14 elements each. So that's where we stop, and I'll quick show you how a periodic table actually looks like. This is how the actual periodic table looks like. As we mentioned, these are the periods, 7 periods. These are the columns. Sometimes the group 1A, 2A, and 3 to 8A together are called as the main group elements, and then to just differentiate them from transition elements, which are these B group elements. And then, as I said, between lanthanum and the next element, between actinium and the next element, there is a gap here, and that gap is filled with lanthanides and actinides, 14 elements, where the f orbital, inner n minus 2 f orbital, gets filled up, and those are called f block elements.